Dear students, I am very happy to introduce the Scalable Data Mining course, which we will be offering in the coming semester. The instructors for the course are myself, Professor Souransghu Bhattacharya from IIT Kharagpur, and my colleague Professor Anirban Dasgupta from IIT Gandhinagar. In this video, we will give you a flavor of the course, of the subject matter of the course, tell you about the course goals and the prerequisites, describe the syllabus for the course and tell you about the objectives of this course. Data science is a field which unifies data mining, statistics and machine learning, and to obtain insights, decisions and predictions from data. It has been observed that the more data we use for obtaining these insights and prediction, the better our predictions and insights become. Hence, data mining or data science on massive data is a very useful thing to do. However, given the current computing infrastructure, it is not always possible to do so. I will describe 3 sample problems where it may be difficult. The first problem, consider a switch through which IP addresses are passing. Generally, switches have very low amount of memory. However, now consider the problem where we wish to find the most frequently occurring IP address in the stream. However, we cannot store all the IP addresses in the which are passing through the switch, which is a large number. The problem is to find the most frequently occurring IP addresses, even though we cannot store the frequencies of all the IP addresses. The second problem, consider that you have a collection of millions of images, some of which are duplicate of other images. A simple calculation will show that comparing every image to every other image will take years of time on current computing hardware. The question is, can we quickly find the near duplicate images approximately without comparing every image to every other image? The third problem is where we consider that you have a large data set of millions of data points, and each of these data point has billions of features, and we wish to classify these data points into different classes. How can we train a classifier on such huge scale by utilizing say hundreds or thousands of servers in a distributed manner? These are some of the examples of problems which we will be dealing with in this course. In this course, we will be introducing the mathematical and the algorithmic tools needed for scaling machine learning and data mining to very large data sets. The course will be a mix of both theory and practice, that is, we will discuss methods which have both a theoretical guarantee as well as which works well in practice. The theoretical guarantees are very important because they allow you to choose the hyperparameters of the systems as well as to debug the systems when you are developing the systems. The main key ideas which play big roles in this course are using randomization techniques, answering questions approximately or solving the problems approximately, and distributed computation, that is using multiple computers to solve the problem in a distributed manner. The prerequisites for the course is mostly self-contained. However, you need to be confident about basic linear algebra such as vectors, matrices and operations on those. You need to be confident about basic probability such as random variable, expectation, variance, things like that. You need to be confident about undergraduate level algorithms course and a data structures course, and you need to have good programming skills. Previous exposure to machine learning will be helpful. The syllabus of the course can be divided into 6 parts. The first part is the background, where we will cover the necessary probability theory, linear algebra, optimization and machine learning background. The second part, we introduce the memory efficient data structures such as hash tables, Bloom filters and various types of sketches. The third part, we introduce nearest neighbor search, which is the data structures which help you answer near neighbor queries in an approximate manner. The fourth part is randomized linear algebra, where we describe how to use randomized algorithms for various matrix factorization related problems. The fifth part is the MapReduce and related paradigms, where we introduce the distributed computing frameworks such as MapReduce and the framework Spark, which is for in memory distributed computing. The sixth part, we introduce distributed machine learning, where we describe how to implement machine learning algorithms on Spark. The learning outcomes from this course are, at the end of the course, you should be fairly familiar with the idea of applying probabilistic techniques such as sampling and sketching in data analysis and data mining. You should know about a few different dimensionality reduction techniques and their connection to data analysis. You should know about the MapReduce programming model, the Apache Spark framework, and will be able to implement machine learning algorithms in the Apache Spark framework. Many large corporations use these frameworks and techniques for solving their problems on massive data such as web scale data processing, finance, Internet of Things and scientific computation. Thank you.